Hello friends, welcome back to the bench. Our subject today is this tiny little preheater that I got for a really good price. I don't remember exactly. I'll show you the listing, but it's very affordable. It is delivered from United States, so I didn't have to wait 3 weeks to receive it. I think from California, and there's not much information on it, but I I do believe I've seen one of these on other channel. I think that was Great Scott's channel, which he uses to basically solder on the components on the board on small tiny boards. Just apply the what do you call it, the solder paste, place the components, turn on the preheater, and it melts in place, and it's all soldered done. I don't do much, designing or building, prototyping or anything like that. I primarily use my tools to repair stuff, right? So how useful will it be to me? Well, let me show you. So one modification that I made to this device is I removed these little screws from here, and I put those little clips, 2 of them, right? It doesn't come with these. Instead, you have just these two screws. Now, the reason for that is, as I said, I don't really do much prototyping. I need to place some stuff over here, something like perhaps a chip, hold it in place so I can wick it, and keep the chip warm, obviously. So that's one modification that I did to it. We didn't get much help from the manual. Actually, well, I did get some help from the manual. And as you know, normally I just throw the manual in the trash along with the box. And because I'm a strong believer that the device should be built in a way that is intuitive enough for a regular guy like me to figure out how it works. This one was a challenge, but the challenge is not because the device is not intuitive, it's because it's in Mandarin, and I do not speak that language, let alone read it. And it's not like I can just use Google Translate to translate it. And let's take a look at it under the scope. So, as you can see, the hot plate there's aluminum on this side, right? It's like aluminum plate, and on this side it has stuck pretty much the wire, right? There's a wire on the back side which dissipates a lot of heat. We see the 2 connections, and that's how we heat up the plate. And those 2 wires going to the middle, that's the thermal feedback, and that's pretty much it. We're pushing energy here, and we're and we're measuring what the temperature is. Nothing more to it. So let's turn it on. Now, one button increases the temperature, the other button decreases the temperature. If you press 2 buttons at the same time, it turns on. Press them again, turns off. Press and hold, and you get into the menu, which is, as you can see, not sure what is done over there. Press and hold again to exit the menu. So unfortunately, there's not much I can figure out from the device how to use the other features, but the feature I'm most interested in is just heating up my stuff that I put on it. So our maximum temperature that we can set is 280 degrees, which is enough to melt solder. And this is where my clips come in handy. If I place, say, this, you can see how wobbly it is, right? It's not even sitting flat. Partially because it's probably slightly bent, although I don't see much bent over here. And partially because, well, it's a PCB. So if I clip it over here, in this case obviously you have to watch out for, so your clips don't actually remove the components while you're working on the board. Let's turn it on. It's on. The temperature is going up. And let's get the fume extractor on because it's going to start smoking. Okay, so the chip is off, as you can see very cleanly, no flags. Now to turn it off, you need to press and hold, or press the two buttons in the back. That's kind of tricky without burning yourself, because it's very small. That's problem number one. Problem number two is when you try to turn it off, you can move the board, which will cause the clips to just move the components around. So what I'm going to do is just disconnect the charger from the outlet. That will turn off the device. And the charger that I'm using is, I think this one's 65 watts. I'm not sure, but this is laptop charger, right? You can't use it with a phone charger because it requires 20 volts. So you need a charger that can deliver 20 volts. Yes, this is 65 watts. And this is the power. 65 watts is the power that this device draws. But since my capability ends at 65, perhaps this device can pull more than 65 watts. We don't know that. But 65 watts, as you can see, it's more than enough to heat it up to about 250 degrees. That was the highest temperature I observed on the display, which was enough to dislodge the memory chip. And since I didn't use any flux, you can see how nice and clean it is. Well, now to clean the pads, I would have to apply the flux, but my board is nice and hot, so this works pretty well. It's really hot, obviously. I did not catch the footage of how it was heating up, but there's not much to see. It's right now at 140 degrees. So it's cooling down slowly. But as you can see, it is very useful, tiny little device, and a really good price actually. Let me check that. So with shipping and everything, it's $22.76. Now considering that it comes without a charger, so you do need to get a USB-C charger for laptops. And this one heated up nicely as well. The charger like this, probably another $25–30. So the whole ordeal will cost you about $50, maybe $60, and you have yourself a really nice preheater. I'm actually really happy with this one, and what I'm going to use it for is mainly what you saw right here. Sometimes I want to remove the chip off the tiny board, and it's usually one of these for data recovery. So all we gotta do is just take the sticker off. This one has a shorter chip, this one. Obviously this one I don't need to recover data from this one, but if I do, well, I have nice preheater, so I just place it on the preheater, heat it up, and take off the chip. It's a lot more reliable than blasting it with hot air, and reliable because it heats up slowly, and I don't need to operate, so both my hands are free. Basically I can use both my hands to work with this, right? So my board is being held nicely to the preheater. It's being heated up to the temperature where the solder becomes molten, and I can use both hands to bake it up. The other use is, as you know, I work a lot with the small QFN chips, and I need to clean them before I put them on the board. So putting them over here, that provides two things. First, preheating, but in this case I don't want to preheat it to the temperature of melting solder. I want to just preheat it to maybe 50 degrees Celsius, maybe not even that, maybe 40, maybe well, 50 at least. I would say 50–60 degrees. That keeps my chip nice and hot, so removing the solder is a lot easier. However, the other part is that I have a chip holder basically, so I can place my chips, use these little clips to hold them, and in addition they stay warm. And here we are, nice and clean desoldering. Very nice. Alrighty, and all that for just $20-some, provided that you have a proper charger to supply it. I didn't get through all the features of this device because I just focused on the features that I need for myself, for my bench. But I'm sure there's features, there's interesting features to it, and maybe I'll take a look at it. Mode options, language options. Yeah, well, I would love to find the language. Chinese simplified, English, yeah. But which one? Oh, actually I can figure it out because it's in Mandarin over here and in English here. So I can figure out how to change the language to English. And CN. Let's look for CN. No, it's only PID. So PID is set menu options. So number 6 is language options. 6. Let's see if we can match the symbol. This seems to be the symbol. English. There you go. Okay. Now it's in English. So it's actually pretty simple. You just have to match this symbol, this one over here. You have to find it and then select your language, which means now we are in English mode. Yeah, so you can set temperature curves. So you can decide how quickly it heats up, would be my assumption. Let's see, temperature. We have max temperature, minimum temperature, and return. Oh, so that's not exactly the temperature curve. Yeah. Yeah. You said max and minimum. For whatever reason. Let's see, max temperature 280. Oh, you can go over 280. Oh, take a look at that. Okay, maximum temperature is actually 350 degrees. So I was wondering about that, because with lead-free solder, which should be this one, this should be lead-free solder, but those chips let go pretty easily. If this was a thicker board and the bigger chip, we would need higher temperature. I'm actually gonna set it the maximum to 340 and minimum temperature. Oh, minimum temperature is 0? I thought it was 50. Oh no, yeah, it was 0. Yeah, I'm thinking of another device. Temperature mode, info, curve, okay. Okay, it just lit up. Info. Oh, okay, so we can either do info or curve. If you switch to curve, you can see it here. It will show, yeah, it will show the temperature as a, yeah, as a graph. That is neat. Let's set it to some low temperature, just so we can observe. 60 is fine. Turn it on. Yeah, all right. So now it's off. Let's go to the menu mode again, and actually, honestly, I prefer it this way. Language, back, PID. PID will be a feedback circuit. Scale factor, integration coefficient, differential coefficient. Okay, let's see. KP, KI, KD. Yeah. Okay, I don't know what these are. Coefficient, but what do they exactly do? Interesting. But yeah, that's something you can mess around with. And that's pretty much it. That's all we have. So that's how you set it to English. English. Oh, and now take a look at that shot. CT. It's set to 64. Now let's try shutting it down and turning it on again, because it looks like a software glitch. Yeah, now it's working. Because the right one over here shows you how much power is being consumed, pushed into the plate, and the left one, the temperature. So we have minimum and maximum, right? So, yeah. Very nice, very neat little device. I wasn't even gonna look into the the language change. And initially I was thinking, well, why would you sell this device in the United States, ship it from United States with the language set to Mandarin, or Chinese simplified as it states here? It's beyond me. As yeah, I understand you don't make much money on the device that you sell for $22 with shipping and taxes and stuff. So maybe you make $2, maybe $5 on each device, I don't know. So I understand the margins are pretty thin, but still, you know, you kind of just expect your customers to be DIYers, I don't know, engineers, I don't know. It's not the best bet. I prefer to receive devices that are actually, that I can tell that someone took care of modifying or configuring the device for the target market, for the target consumer. I don't speak many other languages, and especially not Mandarin, and I know a lot of people nowadays learn that language, either Japanese or Mandarin, but it's I'm not great with languages, you know. So yeah, that's what I prefer to see from the vendors, that we configured this device so you can just, you know, you plug and play. However, the good part is the instructions are actually made really well, because we have pictures and 2 small pages. That's what the instructions should be. One little piece of paper, and it should be easy. And this checks all the boxes. It's easy to use. It's relatively light. It's not. It doesn't feel that cheap. I expected it to be even to feel a lot cheaper than it does, but it doesn't. It doesn't really feel that cheap. If you consider its size, the weight is pretty good. It's pretty stable, right? So if you work with the chips, it's gonna hold your chips really well, provided you have those clips. And those clips actually I got from the microscope. I spent yesterday a few hours thinking about this and contemplating what I can use to hold stuff on it. So I was considering this, right, to clip it on. But on the other side of this plate there are connections, and this could damage it. So I gave up on that idea. I was thinking maybe on this side I would place some padding to you know, to protect the bottom of the plate, but that raises complexity, and then I can only work on the edge. I need to place my chip on the edge of the plate. I would like it to be in the center. That's where the thermal feedback is, and the temperature on the outside might vary a little bit. Not that it would matter that much, but you know, we prefer to keep it in the center. And I was considering those paper clips, those black paper clips, and that would probably work pretty well, but the same problem, we don't want to damage the bottom of the plate. And then I remembered that I have these little things that I didn't know what to do with, because I don't use these for the microscope, obviously, and they work perfectly. I couldn't match the length of the screw, so I had to use instead of using a lot of washers, I just used the little nut over here. And it comes with the springs, and it works really well. I'm actually surprised how well it works. So before I installed those clips, I was thinking that this would be useful if I had some some clips on it, and I couldn't figure out how to actually get it done. But now this device would have been much better with these. So whoever manufactures these, here's a good tip for you. I think it's a great idea to have these, and it won't affect the price of the device significantly. Maybe throw in a couple more bucks for these 2 springs and and two pieces of metal. This is pretty soft metal, so you can bend it however you need it. It works excellent. recommended. Definitely recommended. For this price, I'll take it and I'll use it. Alrighty, fellas. Thank you very much for watching. I hope you found it useful. And I shall see you guys in the next one.